Imaginary and complex numbers. Today we will simplify radicals using the imaginary number I. We will perform operations on complex numbers and we will solve quadratic equations using square roots and imaginary numbers. At the right you can see the graph of the equation y equals x squared plus 1. Notice that there are no x-intercepts. We say that there are no real solutions to this equation. To overcome this problem, mathematicians created an expanded system of numbers using the imaginary unit I. It is defined as I equals the square root of negative 1 and I squared equals negative 1. The imaginary unit I can be used to write the square root of any negative number. We need to memorize these things in this box to the right. I equals the square root of negative 1, I squared equals negative 1, I cubed equals negative I, and I to the fourth power equals 1. I equals an imaginary unit. The square root of a negative number. If r is a positive real number, then the square root of negative r equals I root r. So in the example A, if we have the square root of negative 25, we can separate that into two radicals, square root of 25, square root of negative 1. We know the square root of 25 is 5, the square root of negative 1 is I, and we just simplified. In example B, we can separate negative 72 into the square root of 72, the square root of negative 1. We can then simplify further. The square root of 72 is 9 and 8. 3 and 3 are prime. 4 and 2. 2 and 2 are prime. So we have 2 times 3 times 2. We have an I as the square root of 1. And we're left with 1 square root of 2 underneath the radical. So we have 12I root 2. When we simplify example C, we have negative 5 times the square root of 9 times the square root of negative 1. Negative 5 times 3 times I gets us negative 15I. Example D, we have square root of negative 1. Square root of 27. When we simplify the square root of 27, we can take it a step further and write the square root of 9 times the square root of 3. Square root of 9 is 3. So we have I squared times 3 times root 3. I squared equals negative 1. So our final answer is negative 3 root 3. And in this case, we got rid of all of the i's because I squared is negative 1. When we talk about complex numbers, we need to make sure they are written in standard form. Standard form is when we have our real part plus or minus our imaginary part. So you want to make sure your real part is first, your imaginary part with the I is second. When adding or subtracting numbers, please make sure you always do this. So when adding, if we distribute a positive 1, it does not change what's in our parentheses. 2 plus 5 is 7. 3i minus 6i is negative 3i. We have our real part first, our imaginary part second, and we're finished. Example B, we need to distribute a negative 1, so we have 3 minus I minus 5 plus 6i. When we combined our like terms, 3 minus 5 gives us a negative 2. Negative I plus 6i gives us a positive 5i. Our real part is first, our imaginary part is second. In example 3, we're going to multiply. It's really important to remember that this I squared is equal to negative 1. You multiply your whole numbers by each other, so you get 6. Your imaginaries by each other, you get I squared. Remember, that's negative 1. 6 times negative 1 gives us a negative 6. When we distribute 4i, negative 6 times 4 is negative 24i. 4i times I gives us a positive 4i squared. I squared equals a negative 1. Negative 24i minus 4. Make sure you write your real part first, so we need to rearrange this. Negative 4 minus 24i is our solution. In example C, 9 times negative 4 is negative 36. 9 times 7i is positive 63i. Negative 2 times negative 4 is positive 8i. Negative 2i times 7i is negative 14i squared. I squared is a negative 1. Negative 36. 63 plus 8 is 71i. Negative 1 times negative 14 gives us a positive 14. Negative 36 plus 14 gives us a negative 22 plus 71i. When we look at D and we expand, 5 minus 2i times 5 minus 2i. 5 times 5 is 25. 5 times negative 2i is negative 10i. Negative 10i, positive 4i squared. 25 minus 20i. Minus 4, because remember this is a negative 1. So when we combined our like terms, we get 21 minus 20i. So in this next slide, we just want to recall that we are not allowed to have a square root in the denominator. Because the imaginary unit represents a square root, you must rationalize any denominator that contains an imaginary unit. To do this, you are going to multiply the denominator by the complex conjugate. So example 4 says state the conjugate for each. So if we are looking at 2 plus 3i, the only sign that's going to change is the one in front of the imaginary unit. So our conjugate is 2 minus 3i. In example B, the only sign that's going to change is the one in front of our imaginary unit. So our complex conjugate is negative 3 plus 3i. And when we are looking at just 0 plus 2i, the only sign that's going to change is in front of our imaginary unit, so the complex conjugate would be negative 2i. So example 5 says simplify. A says 3 plus 10i over 5i. We need to rationalize our denominator to get rid of the imaginary unit. So we are going to multiply both the top numerator and denominator by negative 5i. When we distribute negative 5i to everything in the numerator, we get negative 15i minus 50i squared. In the denominator, we get negative 25i squared. Remember, our I squareds equal negative 1. So when we multiply by that negative 1, we get negative 15i plus 50 over positive 25. So then when we go to simplify, we want to make sure it's written in standard form, so put your imaginary part second. We then can look at these three numbers, and if they are all divisible by the same thing, we can reduce. So they are all divisible by 5. So when we reduce, we get 10 minus 3i over 5. In example B, the complex conjugate would be 4 minus 2i. Whatever you do to the bottom, you must do to the top. When you distribute this out, you get 8 minus 4i plus 32i minus 16i squared. In the numerator, the denominator, we get 16 minus 8i plus 8i minus 4i squared. When we multiply or replace our I squareds with our negative ones, we get 8 plus 16 plus 28i all over 16 plus 4. Simplify again, we get 24 plus 28i over 20. All three of our numbers are divisible by 4. 24 divided by 4 is 6. 28 divided by 4 is 7 i's. And 20 divided by 4 is 5. Your complex conjugate in example C that you would multiply by would be 2 plus I. When you distribute those out, combined your like terms, you should end up with 7 plus 6i over 5. Because these three numbers are not divisible by the same thing, you would be finished.